Okay, good morning, dear students. Let's start our lesson. So today our lesson is SolidCAM. So we today learn the three axis, the roughing operations. The last lesson we have seen the planar operations, and here that our SolidCAM. And as usual, you need to here go to the milling. Here the milling operation. Then here you need to select here the external SolidCAM project, and here you can define your the project name. For example, I will call it the project 2. That's the second project hour, and here you need to define your the unit of the measurement. So the metric is we'll select here the metric is our unit of the measurement, and click OK here. So SolidCAM will open it, and here the milling part menu will open it. And what you need to do here, the first you need to define your the machine, that is the post processor. So here if you open this list, that you will see here the list of the machine, that's CNC machine, that's that post processor that is used here in the SolidCAM. Then you can use for example, any of them according to the machine. So let's use here the Fanuc machine, the CNC machine. And here that you need to define here the coordinate system, the stock value and target. The target will be automatically defined after you define your stock value according to the shape. So this is our the workpiece, the model, that's our the target. So let's define here the first the coordinate system. That click here the coordinate system to define the coordinate system, and here we have the several options to define our the coordinate system. You can just here use the face option. Just click here the top face of the model. So the coordinate system will be generated here. You can see the coordinate system, and this is the here you can see that that's the option the top of the model on the box, or you can go to the top of the model on the box here on the corner. So if you selected this option, that will be the generated on the corner. So here let me go here just here you can define here the origins and so on. So let me just click here OK. So it will be generated here, and our 0 point, and click OK. Just click OK here again. Then let's define here the stock, our raw material, go to the stock. And here that you can, last time we have used here the box option. Now we can here the several option. That's the 3D model we can use. So we can use the cylindrical, that is mostly for the turning operation, that's the stock. And we can use here the extrude post, extrude boundary. So last time we have used box. That 3D model is used when you created your the stock in the SolidWorks. It is the model, extruded model, but in this case we don't have this one. Then STL model is used, for example, that when you created the project, that's the SolidCAM, then for example the milling operation, then you will save this operation and STL format. Then in order to open this you will use here this one for example for the turning operation and so on. Now let's use here the extruded boundary option, that's in this case. And here you need to select here the lower boundary, the edge, and here you see this will be the take here the model, that's the stock, exactly with the same with our the model, and click here the yes. So this is our the stock, which is the exactly the same with our the model, the height and so. And now click here the OK to accept our the stock. and target is also the selected. It's the automatically, and here you can define some options. For example, the material you can define here you can define here let me just go here the machine. That's the here you can define here the material of your product, of your the model here. Let's make here, for example, cast steel. That is one. So here you can define the material, and now you can here go to click here to OK to accept initial setting for the SolidCAM. So we now made here the initial setting. Now we will go with the operation. So here select here SolidCAM operation of this available here the menu, and the last time that we have seen the 2D option, that's the face profile pocket, that the drilling operation. Then today also we have to see the some of them, but now I want to highlight here the another option, that is here the 3D high speed roughing operation. Then if you open here this one, so we have the several options for the roughing operation, and they are always the roughing operations. So it is the mostly used for the remove the large portion of the stock material from the model, and mostly used for the molding operations and so on. So it will be the roughing operation, and some material will be the remained as usual after this operation. So let's see here the step by step how to use this operation. So let's start from the first one. It's the most commonly used and the most frequently used option. So let's here the high machining. This the roughing operation. Click here this roughing, and here open this roughing operation. And what is the important in the geometry here? Here that's the target is selected. It means that it automatically recognized the target model from the stock value. So in this case it is here is selected. That will now we will go here to create the tool for this operation. Click here the tool, and click here the select, create your tool. So for the roughing operation we will use here the end mill. So here the tool for the roughing operation, and double click on this one to create your tool. And here you can see your tool the dimensions, and if you click here these dimensions, and you will see here that is the highlighted that which dimension is here. So we can change here the values. So let's create a tool, for example with the diameter of the 20 millimeter for the roughing operation, and here the other parameters will automatically adjust the values according to the diameter. So let's keep here the all values like here, and we can go here to this one to cutting condition, and we can define the cutting condition here. That's the speed, the rotational speed of the spindle. Also, we can define the spindle rotation, is the clockwise or the counterclockwise. So you can define any of them. Also, you can define here the values. So according to the tool characteristics, you can define the method of the measurement. So it can be the millimeter to the tooth, or the millimeter by the meter, or you can make here the RPM, that's rotational per minute of your the spindle, or is the meter per minute. So you can define by yourself this one. Now here click here the select to accept this tool for this operation. So you see that tool is created here. That's the tool. That's the end mill. Now we will go to the constant boundaries, constraint boundaries. In this case, we need to define here the cutting areas. So the cutting areas, and cutting area that could be created automatically or created by the manually. So you see the cutting area is defined manually in here, or you can create automatically. So it's the better to use here this option, since here it will define the cutting area automatically by the system. according your the model shape and your the stock. So keep here the this one, and now go to the passes. So in the passes that we will define the here the first one is the wall offset. That is the remaining material in the wall. So you can see here the illustration that is the in this case 0.5 millimeter, and you can define this value. So any value. So when it's the and here you can also define the non-material on the floor. That is the remaining material on the floor, and here is the tolerance, and here is the step down. So it is the cutting direction along the z-axis, as now that's the depth of the along the z-axis, and here is the full that's the tool diameter, and you can see here that the percentage of the tool diameter that's the along the in the direction, and or you can make here the step over option with the sum that distance, or you can make here that step over in the percentage, and this is the let's keep here these values, so you can adjust these values as you want, that any value, and here that's top level that you can define here the top level, and go to the select here this face, click OK, and go to the bottom. Let's define your the bottom face of the model here, so click OK. So we defined our the passes. Now go to the link. In the passes, you can go to the step down. So the is the these options, and you can keep here this one. Then go to the link. So the link is to just as usual. That's the first interaction of your the tool with the our the workpiece. So here you can define the clean milling or the conventional milling. Is the clean milling is that your the tool in the conventional milling, you see the tool rotation is the opposite to the feed weight. In the clean milling, tool rotation is the same as the tool as the foot the feed. So you can make here clean or the conventional, and here you can define the in the retract. You can define your the start point. So you can, for example, activate this one and define your the start point coordinates here. The in this case it's 0 0, it's 14. You can make here the more higher, for example, let's make it 100. It's the start point, and you can activate this one, though it will be activated. It means that the turn point will be also the same, so it will your the tool after making the machining operation, it will return to the this that 0 point. So you can activate these options also. And here you can go to the ramping. So in the ramping, that will be the interaction of your the more that's the tool that's the with the your the workpiece, and here you can make here the helical ramping, and you can see here is the helical, or you can make here the straight ramping is the planche ramping. So it will go to the first interaction of your tool with the workpiece will be destroyed. So it's the better to use here the helical. So it will be the helical ramping into the workpiece, and you can define here the angle of the helix and so on, and diameter you can define the helix and so on. So now we defined that the settings for the roughing operation. So we can go to the here the save and calculate to generate our the tool test, and click the save and calculate, and it will calculate here the all your the cutting conditions. So that's you need to wait some time. So it is the finished here. Then you can see here our tool pass, and here do you see this is our the starting point, which we indicated as 0 0 and 100, and it will go and return to this position. Then let's go to the simulate, and let's select here the solid verify, and just click here the play to see our the simulation. So you see it is the helical, it's the ramping. You can speed up. So this is the roughing operation. That's the most commonly used to remove the large portion of the material. Some material will be the remainder. So then we will see the operation. That's the for tomorrow for the finishing operation. It is just the roughing operation. And you see that it is the finished, and some material on the floor and the walls is remained, which we indicated in our system, that is in our setting. And you can here go to the click here the G code to generate the G code for this operation as usual. But I want to just close this one, and here this is our the operation, and here that is that we have used this one. But here we have the other operations, that is the for the roughing is the counter roughing, that is the hedge roughing. Then we have also the hybrid roughing and the rest roughing. So they are all the mostly for the roughing operation. Then let's use all of them step by step. So for example, in the counter roughing and hedge roughing, they are similar, but in the hedge roughing, that your the tool path that will be the in the zigzag form, and the counter roughing that will take the tool path according to the shape of your tool, and so on. So in the hybrid roughing, that you will add one more the finishing operation, the additional finishing operation after the roughing operation. And the rest roughing is also the roughing operation, and which is the called as a semi-finishing roughing, and it will be the performed after all this roughing operation, in order to remove some portion of the materials which is the tool is cannot be reached. So it is the semi-finishing, the semi-roughing operation. So let's see for example, start from the counter roughing. In order to do this, I will just delete this my roughing operation which we created. Just click here the delete. Yes, so here go to the again here to go to the counter roughing. So, and here you see it was created here the counter roughing, but you can change here the option as you want here that we have used here the roughing. But now we are in counter roughing. You can change here the roughing. Here that will be the roughing operation, but we will use here the counter roughing. Again, in the counter roughing, that should be the target. Target should be the selected, so it will define your the target and your the stock. Now let's go to the tool and click here the select, and we can use here the tool which we created before with the end mill with a diameter of the 20 millimeters. So you see here it is the exit here. So or you can create another tool. Now I want to use the same tool. Click here the select. And again, the constraint boundaries. So let's create the constraint boundaries automatically. So it is the defines the automatical, and here the pass. So in the passes, you can define here the wall offset, the floor offset. That's as you want, and you can define the step down. And here you can define here the top level as usual. Let's go to this one top level. Define here the top level and click OK. And as a bottom level of your workpiece, and define here the bottom face of your model and click OK. And here you can activate, for example, here the detect the flat angles. Let's activate here that will detect, and you can disactivate this one, or we can here the smooth the toolpath, and you can detect that here the core areas just like here, so it will be activated. You can define here the corners. So if I activated this one, the corners will be the rounded. So like here we can disactivate, it will be the straight corners. Let's deactivate this one, we can the corners rounded. And here you can go to the adaptive the step down options, and you can here define some values. So it's the step downs that's along the z-axis, and you can go here these values. And let's go to the link again. Again, in the link, you can define here the option is the clamp milling. That's the for the conventional milling. And you can define here the again the retract. That's the same that we have done in the roughing. So let's make here again 100 millimeters and keep here the return the same to this point. And the ramping also the same. You see the helical should be the more that's the more suitable. So this is the here the route to strategy. So you can then define the strategy. So it is enough for this operation. And last, we can go to the safe and calculate again to generate our the toolpath. So here you see the toolpath is generated for the roughing operation, and the difference is that it will be the counter the toolpath, and go to the simulate, and here they go to the solid verify and click here the play. And this is also the roughing, and here you see it is the counter toolpath, so it will start from the outer periphery and go to the center point, so it takes the counter shape of the model. So it is the for the roughing operation is also they can be used. So so this is this one. So we can go to the strategy. Let's see here the other option. Will go to the general and go to the passes. So I can close here, and let's delete this one. Let's click OK. And here let's go to the hedge roughing. So they are the same as counter roughing and with the hedge roughing, but here different is in the hedge roughing, that is the toolpath will be in the zigzag form. So the you can use any of them. So the roughing, counter roughing, or hedge roughing for the roughing operation. So they are almost the same, but toolpath will be the different. Go to the hedge roughing, and here you see the hedge roughing is selected here option, and again that's usually that's the target should be selected, and we will go with the tool. We will go with the tool, and again let's go to the select here that okay, let's use the same tool. It's the end mill with the diameter of the 20 millimeter which we created before. Let's click OK, and again constraint boundaries, just keep here that's automatic option. Again to the passes, so we need to here specify the passes. So you can make here again that's the activate these options, and you can here the go to the link again, just define here this one. Then in this case you see here that we have the one option that you can make here or you can make here the zigzag option be directional, and define is because the tool is moving in the zigzag form. Then you can make here again define here the ramping. So the ramping is the tool, the interaction that with the workpiece. So you can define here the retract that plane here. That's to make here the 100 here again. Then just go to here the save and calculate. Here you see the toolpath is the zigzag. So in the counter, the roughing it was the counter. So this difference is just in this. So in the toolpath. So go to the simulate and click here the solid verify, and just click here the plate, and you see the toolpath in the zigzag form. But the generally is that they are the same. That is the three roughing operation which we have seen. They are the same, but the difference is that in the toolpath they are different. So here materials remained. So and next here I want to show here this one is the rest roughing. So the rest roughing is used. Here the mostly is the semi-finishing, that's semi-roughing operation. After this the roughing operation, then it will be the used to remove some portion of the material which is the cannot be reached then from the previous operation. Again, in the rust roughing, that is the geometry should be selected as a target here, so it will define the stock and the final product. That's this systematically and as a tool. And let's create here the tool. Let's create a different tool. Let's again the end mill, but with the lower diameter, with the 6 mm of diameter here. And you can see in our the list that we have created the second tool with the diameter of the 6 mm. Let's click OK here. And as a constraint boundaries, let's keep here this option again. That's automatically defines our the stock and our the final product. And as a pass that you can here define here the lower, because we are making this the semi-roughing operation. Let's make here this option. Step down. Let's keep here the one. It's the along the z-axis. And you can make here again activate these options always. So, and go to the link, and the link, let's keep all the operation, and you can define here again the same starting position and the return position, and click here the save and calculate. So this will be the generated our the toolpath. Then click here the simulate. Let's make here the solid verify, and click here the play, and here you see this started to operate, and this is the semi roughing operation. Anyway, that some material will be the remaining for the further the finishing operation, so it will remove the some portion. So it is the semi roughing operation or the semi finishing operation here, this one. So we can close this one and close this one. So here we can see here we have the two passes. So the blue one is for the roughing operation, and here the orange is for the semi-roughing operation. And we can deactivate, for example, our semi rough operation here by deactivating this one, or we can activate our toolpath, or we can deactivate our toolpath for the roughing operation by deactivating here, and to see our the toolpath for the semi-roughing operation. So in conclusion, that we have seen here the some basics for the roughing operation that most commonly used is this one. That's just the roughing. But we can use here the counter roughing or a hedge roughing. This is the for the again it's the roughing, but here the several the different the toolpaths. Here we have the zigzag, and here we have the counter the toolpath. And also we can see here, we have seen here the rest roughing is the semi-roughing operation, and mostly is used after this roughing operation to remove the some portion of the material, which is the tool cannot be reached. So this is this one. Now we will see the last option, that's the hybrid reroughing. And the hybrid roughing that we will add one more additional passes after the roughing operation is the finishing operation. So let's see that this one, not to do this, I will delete these two the operation. So delete here these operations. So we'll click here the yes. So now go to the here the again open here hybrid reroughing. And here the hybrid reroughing option is activated here in the list. And again, in the geometry, what is the important that you need to select here as a target. And here you will see it is used to create this kind of tool passes. Let's create our tool, select our tool, click here the select, and let's use the second tool here with the diameter of the 6 mm, the end mill. Then click OK. That's the boundary. Let's create this again. That's the automatic, and go to the passes. And here that we'll define here again the wall and the floor, the material is after this operation. And what is the important here, you can see here the roughing and finishing operation. And here that you can see here the roughing and the finishing operation, and the individual we will define here. The first is the roughing operation is the step down. So it is the step down, and here you can define here then this our the finishing operation. So it is this is they can define here the step down for the finishing operation, and number of the levels for the step down. So you can increase here the number of the levels if you want to make here the more the precise the value. So you can make here the number of the offsets and so on. So you can go to the link again. In the link you can define here the ramping, and you can go to the here the attack plane, define here the attack plane, and that's the plane here. That click here this one, and generate here the save and calculate. So let's go to the simulate, and here that we have the two passes. So let's go to the solid verify. Let's decrease the speed. Let's go. So tool pass is start to generate it. So we can just speed up our operation, the simulation. This is the first test, the roughing operation. Then the one pass of the finishing will be the generated after making the roughing operation here. So let's okay. Now let's go with the simulation. So this is our operation. So can close this one, and now we have learned here the basic roughing operations. This is the three axis of roughing operation. It's the starting from the just single roughing, the counter roughing, hedge roughing, the hybrid roughing, and the rest roughing. And most commonly used is this one for the just creating the simple roughing operation. In the most cases for the creating the cavities in the molding generation, and in the casting operation. So to create the G code that this operation is used, but you can use the other options like we have seen here. It is a simple operation. Let's create the G code. So let me just here, and in the next lesson that we will see here that this one is a 3D high-speed machining, and this is the for the use, that's the finishing operation. And we have the several options for the finishing operation, and that is the use to create the final operation, that's finishing, that remove all the material which is the remaining after which we have seen after the roughing operation. But now here I will stop here the here.